Okay, so for example number 6, it says for each function, tell the intervals in which it is increasing and the intervals in which it is decreasing. So as I look at this graph, so we've got x plus 2 squared, and that's a parabola, right? Whatever number I plug in for x, it's going to give me like a parabola shape. It's a parabola that's shifted to the left 2 units. You guys remember that? So since it's shifted over to the left 2 units, it's just a basic parabola, right? So when is this function increasing? Well, it's increasing when the y values go up. And it's decreasing when the y values go down. So I would say that it is increasing from the vertex, right? Not vortex, vertex. From 2 all the way to positive infinity. I would say that it is decreasing from negative infinity to 2, right? So as I read this like a book, my y values are decreasing right up until I get to the minimum or the vertex, and then it reverses course and the y values begin to increase. Does that make sense? Now, why does that happen at 2? Well, we'll dive into that in a little bit, but we'll really dive into that in calculus. So just like our previous example, if this represented stocks, and this was the price of stocks, when would you want to buy that? So I don't necessarily care about all this stuff in between. I just don't want to buy it until x equals 2, whatever that represents. And I definitely wouldn't want to sell it anytime here, because if I sell it here, I might lose money or whatever, you know what I mean? And I certainly wouldn't want to sell them here. I want to buy here, sell up here, right? What if I owned a bunch of stocks and I saw it was coming down, coming down, coming down, coming down? Well, if I sell my stocks now, I'll lose money. But if I had some sort of predictor, some sort of mathematical equation that I had some confidence in, I would just hold on to my stocks till the price came back up. So this happens several times a day. And I got this really cool video. We don't have time to show it to you guys today. But there are people that program computers that just watch to see when stocks go up and when they go down. They buy them right before they're about ready to increase, and they sell them right before they're ready to decrease. And they only make a couple cents a share, but they do it with millions of shares. So they literally make thousands of dollars an hour. And the computers do it automatically. And they build computer systems, and they place them in servers near the New York Stock Exchange, because if they buy it a fraction of a second too late, in other words, if they were in LA and they tried to purchase the stock, within a fraction of the second, the value either goes up or down, and they lose money. So they go to great lengths, and it's just a computer that just watches things, predicts, buys and sells when appropriate. Isn't that something? That's what I need to do. All right, so now let's look at this one. When is it increasing? When is it decreasing? Well, from here to here, what would you guys say? Increasing or decreasing? From here to here, what is the function doing? Increasing or decreasing? Increasing, good. All right, trick question. From here to here, what is it doing? Still increasing, right? So now we've got this crazy discontinuous function, infinite discontinuity. All right, from here to here, what's it doing? Decreasing. You could tell because I had my yellow marker, right? All right, so it's decreasing there. And from here to here, what's it doing? Decreasing. Okay, so what we said is the pink stuff is increasing and the yellow stuff is decreasing. That's pretty simple, isn't it? So even though you have like a lot of homework tonight, what are you going to do? Just graph it in your calculator and figure out. Now, when is it? If I write this down though, when is it increasing though? That's the key thing. When is it increasing? It's increasing from negative infinity to negative, or from negative infinity to negative 1, and then it's also increasing from negative 1 to 0, right? Why didn't we just say negative infinity to 0? Why didn't we say that? Because the function has a vertical asymptote at x equals 1. If we go back and look at the original function, can x equal 1? This is the function. What happens when x equals 1? 0 in the denominator. What happens when x equals negative 1? Still 0, right? So x can equal 1 or negative 1, so we have vertical asymptotes at negative 1 and 1. And so therefore, x doesn't equal 1, and so we have to be very careful. We say that this function increases from negative infinity to negative 1, also from negative 1 to 0. Likewise, we kind of have to do the same thing on the decreasing end. We say that the function decreases from 0 to 1, right? And then again, it decreases again from 1 to positive infinity. So on your homework, you do have to be a little formal, right? It's just a tad more than looking at the graph. Now, how do we know that the 1 is the number? It's the domain restriction, right? So if we come back up here and we look at this, 1 and negative 1 are the domain restrictions. Those are the numbers that's going to make the denominator equal 0. Are there any domain restrictions here? No. There's only two types of domain restrictions: negative even roots and zeros in the denominator. That's it. Okay?